All right. I'm genuinely excited about this deep dive because, well, what if one of the planet's oldest life forms actually holds some surprising answers to our most pressing modern health challenges?
Things like managing weight and cholesterol.
Exactly. It sounds almost too good to be true, doesn't it?
Yeah.
But that's exactly what we're going to unpack today.
Okay.
We're focusing on a truly fascinating organism, a cyanobacteria widely known as spirulina.
Right, the blue-green algae everyone talks about.
That's the one. And there's this rapidly growing scientific interest in it as a potential nutritional powerhouse, and, for good reason.
Makes sense.
Our mission with this deep dive is really to cut through the noise, extract the most important insights from a pretty comprehensive scientific review, and zero in on spirulina's effects on, specifically, weight loss and blood lipids.
Got it. So the core metabolic stuff.
Exactly. We want to uncover the surprising, intricate science behind these claims and ultimately provide you, our listener, with a powerful shortcut to being truly well-informed on this topic.
And the source.
Yes, good point. Just so you know, our primary source for today's discussion is a recent scientific review published on PubMed Central. That's a government website, so.
Solid foundation.
Right. Gives us a really solid, reliable foundation for everything we're about to discuss. Okay, let's unpack this. We're diving into something truly ancient with very modern implications.
Yeah, and what's fascinating here is how something so fundamental as blue-green algae, something that's been around for billions of years, could be linked to such prevalent and pervasive health concerns as obesity and dyslipidemia, which are just unfortunately so widespread in our contemporary world.
It really is striking.
It speaks volumes, I think, about the potential simplicity in addressing what often seem like overwhelmingly complex issues.
That's a crucial observation. And to truly appreciate its potential, we first need to understand what this ancient powerhouse actually is. Let's peel back the layers on this remarkable blue-green algae, or rather cyanobacteria. It's been around since, practically the beginning of life.
Right. Often loosely referred to as blue-green algae, scientifically it is a cyanobacterium.
And think about that for a moment. We're talking about one of the oldest life forms on Earth, a true ancient microbe that has adapted, evolved, and thrived for literally eons. Its resilience and longevity alone are just, remarkable.
Indeed. And it's quite something to consider its natural habitat, too. Spirulina is incredibly versatile. It grows in both fresh and saltwater sources.
Okay.
However, it particularly loves and really thrives in high-salt, highly alkaline water reservoirs.
So pretty extreme conditions.
Exactly. These unique conditions are found naturally in subtropical and tropical areas across the globe, places like America, Mexico, various parts of Asia, and Central Africa. These natural environments really speak to its hardy nature and its ability to flourish in conditions many other organisms might find challenging.
So it's adaptable, tough stuff. And what's interesting is its journey through scientific classification. It wasn't always clear exactly what it was it?
No, not at all. Its classification journey is actually a fascinating tale in itself. Initially, it was grouped with plants.
Right, because of the green color and photosynthesis?
Precisely. Largely because of its rich pigments, those distinctive blue-green hues, and its profound ability to photosynthesize, much like, terrestrial plants do. This led early scientists to categorize it within the plant kingdom.
Makes sense.
But as scientific understanding and technology advanced, deeper examination of its genetic, physiological, and biochemical makeup revealed a clearer picture. Scientists ultimately recognized it for what it truly is, a bacterium, specifically a cyanobacterium. And this distinction is vital for understanding its unique biological properties. And among the numerous varieties out there, the most commonly studied species in research, the ones we'll likely be discussing today, are Spirulina platensis, Spirulina maxima, and Spirulina fusiformis.
Got it. And it's not just ancient history. It's a nutritional powerhouse. I mean, this isn't just some, pond scum we're talking about.
Chuckles. Definitely not.
Spirulina is absolutely packed with beneficial compounds, a true superfood in the most literal sense. It contains numerous antioxidants. We're talking powerhouses like beta-carotene, phycocyanin, and tocopherols. It's rich in a wide array of essential micronutrients that our bodies crave, and it boasts a significant content of polyunsaturated fatty acids, particularly the incredibly beneficial gamma-linolenic acid, plus a whole range of phenolic compounds. It's just loaded.
And its historical recognition truly paints a vivid picture of its high nutritive value. If you cast your mind back to the 1970s, The Intergovernmental Institution for the Use of Microalgae Spirulina Against Malnutrition was specifically launched, its purpose, to combat starvation and malnutrition globally using this very organism.
Wow, that's a huge endorsement.
Think about the impact of that initiative. It was seen as a vital tool in addressing one of humanity's most basic and, frankly, devastating challenges.
And if that doesn't convince you of its incredibly high nutritive value and efficiency as a food source, get this. Both NASA and the European Space Agency have not only recognized but actively recommended spirulina.
For astronauts.
Yes, for food supplementation during long-term space travel. I mean, think about it. If astronauts facing extreme nutrient limitations and demanding physical conditions in space are being given spirulina.
That tells you something.
Right. That tells you everything you need to know about how incredibly potent, dense, and efficient this organism truly is. It's like a complete survival package.
Indeed. It's a testament to its unparalleled nutritional density. Now, beyond its impressive nutritional profile, a natural question many listeners will have, especially when we talk about supplements, is about its safety.
Always important.
Because that's always a crucial piece of the puzzle. And the good news, which the source emphasizes, is that spirulina is noted as a low-cost nutritional supplement with no significant established side effects.
That's great to hear.
This broad safety profile, combined with its nutritional benefits, is a significant part of its appeal, you know.
That's a huge relief, especially when we're talking about something so potent. And, while our deep dive today is laser focused on weight loss and blood lipids, it's worth briefly touching on its broader reported benefits.
Just to show the range.
Exactly, just to illustrate its incredible versatility and multifaceted nature. The research mentions a vast array of properties: antiviral, anti-cancer, antioxidant, anti-diabetic, anti-inflammatory.
Wow.
Hepatoprotective, meaning liver protecting, cardioprotective, which is heart protecting, and of course, immunity boosting properties.
That's quite a list.
It is. Here's where it gets really interesting. This isn't just about weight loss, but a whole suite of potential benefits that could influence overall well-being.
Yeah, and if we connect this to the bigger picture, spirulina's profound historical use, coupled with its extraordinarily diverse nutrient profile, well, it truly sets the stage for its potential in addressing some of today's most widespread and interconnected health issues.
Like metabolic syndrome.
Particularly those associated with what we broadly term metabolic syndrome, yes. It's not merely a single target solution for a specific ailment. Its multifaceted nature, impacting various physiological systems, positions it as a key player in potentially influencing a cascade of positive health outcomes, which is, frankly, a rare and highly desirable characteristic for any natural compound. It's like a holistic approach from a microscopic organism.
That truly is a crucial observation, because as we just highlighted, spirulina could represent a remarkably simple yet profoundly effective solution to some of our most complex and pervasive modern health problems.
Right.
So let's delve into one of those monumental challenges, the global obesity crisis.
Yeah.
The statistics are not just stark, they are truly alarming.
Yeah.
Globally, obesity has nearly tripled since 1975.
Tripled.
Just let that sink in for a moment, a threefold increase in less than half a century. It's staggering.
And the numbers just keep climbing. In 2016 alone, for instance, over 1.9 billion adults worldwide were categorized as overweight.
1.9 billion.
And a staggering 650 million among them were classified as obese. These aren't just abstract figures. They represent an immense, escalating global health burden.
And the consequences?
They're dire. Approximately 2.8 million adults are estimated to die every single year from obesity-related causes. This isn't merely a cosmetic issue. It's a profound public health emergency with very real life and death implications.
It's an epidemic, plain and simple. And what's critically important for us to understand here, I think, is the deep, often overlooked connection between obesity and inflammation.
The inflammation link, yes.
Obesity isn't simply about carrying excess weight. It's intricately linked to a chronic state of low-grade systemic inflammation.
Right. It's not passive.
No. And this inflammatory state often goes hand in hand with hyperlipidemia, which is essentially, too much fat sloshing around in your bloodstream.
Like grease in the pipes.
Exactly.
Well,
a bit like too much grease clogging your body's plumbing system and insulin resistance. They often travel together.
Precisely. And to expand on that, the adipose tissue, or our fat tissue, isn't just a passive storage depot for energy. Far from it.
It's active.
It's a highly active, dynamic endocrine organ. Think of it as a busy chemical factory within your body.
Okay.
This factory actively secretes numerous biologically active substances, including vital chemical messengers like adipokines and chemokines.
Right, I've heard of those.
In a healthy state, these messengers play important roles, but in the context of obesity, when fat cells become enlarged or hypertrophied,
They make too much.
exactly, these substances get produced in excess. In essence, they act like inflammatory flares, sending signals throughout your entire body that contribute to widespread systemic inflammation and significantly contribute to the development of atherosclerosis.
The hardening of the arteries.
Yes, the dangerous hardening of the arteries, a major risk factor for heart disease and strokes.
So, if obesity is essentially fueling this insidious inflammatory fire within the body, how does spirulina step in? How does it potentially douse those flames and maybe break that vicious cycle?
Good question. Let's dive into its specific anti-inflammatory mechanism, the how behind its action. The source points to a fascinating biochemical pathway involving a key component found naturally in spirulina. The phycocyanin, that beautiful blue-green pigment we mentioned earlier,
Right.
in spirulina contains a light-harvesting chromophore called phycocyaninobilin.
Phycocyaninobilin. Okay.
And here's where the magic really happens at a cellular level. This phycocyaninobilin has a remarkable capability. It can effectively inhibit nicotinamide adenine dinucleotide phosphate hydrogen oxidase.
Whoa, okay. NADPH oxidase. That's a mouthful.
Tickles. It is. NADPH oxidase. Let's simplify it. Think of NADPH oxidase as a tiny, sort of overzealous factory operating within our fat cells,
Okay.
relentlessly churning out inflammatory compounds and generating excessive oxidative stress.
Got it. Bad news.
Very bad news. This oxidative stress, particularly in those hypertrophied or enlarged fat cells, plays a pivotal role in inducing insulin resistance and detrimentally altering the production of those signaling molecules like adipokines and cytokines, which then just perpetuate systemic inflammation. It's a feedback loop.
So if I'm understanding this correctly, spirulina, through its phycocyaninobilin, essentially puts a brake on that inflammatory factory. It calms the cellular chaos.
That's a great way to put it.
It's not just addressing the symptoms, but influencing the very root cause.
Exactly. By suppressing this adipocyte oxidative stress, spirulina may lead to widespread anti-inflammatory effects throughout the entire body, and crucially, it can also have insulin sensitizing effects.
Wow.
This positions it as a truly promising adjunctive treatment, meaning it can work alongside traditional and foundational approaches like caloric restriction and regular exercise.
Right, not instead of, but with.
Precisely. And this raises an important question for us. Rather than merely addressing the surface-level symptoms of obesity and metabolic dysfunction, could spirulina be influencing the much deeper underlying inflammatory and oxidative processes that primarily drive these widespread conditions?
It suggests a more fundamental intervention, doesn't it?
It really does.
So what does this all mean for you, our listener, if you're exploring new approaches to managing your health? It's about moving beyond just, counting calories or steps. It's about tackling the root causes of these conditions.
Yeah.
It's about getting to the cellular and molecular level of what's going wrong in the body when excess weight, high lipids, and chronic inflammation take hold. It's a more sophisticated way of thinking about natural interventions, perhaps.
Yeah.
All right, so we delved into the what of spirulina, understood its historical significance and incredible nutrient profile, and explore the theoretical how behind its anti-inflammatory and metabolic actions. Now it's time to shift from theory to tangible evidence.
The human study.
Exactly. Mm-hmm. What do the clinical trials, the actual human studies, show regarding spirulina's benefits for weight loss and body composition? The sources highlight several compelling studies that paint a pretty clear picture.
Indeed, the empirical evidence is growing. One notable study, for instance, was conducted by Youssaifi and colleagues back in 2018.
Okay, Youssaifi et al.
They investigated 52 individuals classified as obese, specifically those with a BMI between 25 and 40 kilograms or honest. These participants were randomized into two distinct groups.
Spirulina versus placebo.
Right. One group received 2 grams of spirulina per day alongside a carefully restricted caloric diet, while the control group got a placebo, also coupled with that restricted calorie diet, for a duration of 12 weeks.
12 weeks, okay. And the results?
Pretty significant. The group that received spirulina showed a considerable reduction in body weight, averaging approximately 3.22 kilograms.
Which is almost 7 pounds. That's not insignificant.
Not at all. Their waist circumference, a crucial indicator of visceral fat and metabolic risk, decreased by an average of 3.37 centimeters.
Also good.
They also saw a notable reduction in body fat, down by 2.28 kilograms, and a BMI reduction of 1.23 kilogram per milliliter.
Okay, so hitting all the key weight metrics.
Yes, but what's particularly compelling about this study, beyond those direct weight metrics, is that they also observed additional systemic benefits.
Like what?
Triglycerides were reduced by 18 milligdl, and high-sensitivity C-reactive protein, that key inflammatory marker we discussed.
Right, HSCRP.
That was significantly lowered by 1.66 ng/ml.
Wow. So these aren't just small shifts in numbers. We're talking about tangible, meaningful changes in body composition and, importantly, a reduction in systemic inflammation. That's huge.
It really is. What truly stands out from the Yousefi study isn't just the sheer amount of weight loss, but how it points to spirulina's potential to address those systemic issues like inflammation.
The underlying drivers.
Exactly, which are often the true drivers behind stubborn weight gain and metabolic dysfunction rather than just being, a temporary fix. It suggests spirulina isn't merely acting as a metabolic stimulant, but influencing the very environment of the fat cells.
Tackling the environment, not just the quantity. I like that. Now let's look at another study that focused on appetite, which, as anyone trying to manage their weight knows, is a critical factor.
Absolutely crucial.
This was Zinalian et al. In 2017. They conducted a trial involving 62 obese subjects. These participants were administered 1 gram of spirulina per day for 12 weeks. A lower dose, right?
A lower dose, yes, 1 gram. And what they observed was quite insightful, a significant reduction in appetite, specifically by a notable 4.16%.
Almost 4.2% reduction in appetite. That could make a real difference.
It could. And alongside that crucial reduction in appetite, this study also reported a modest but statistically significant BMI reduction of 1.9% and a body weight reduction of 1.79%.
Okay, so smaller weight changes with the lower dose, but still significant. What about lipids?
In terms of lipids, they found that total cholesterol was reduced by 4.67%, and importantly, HDL-C, the good cholesterol.
Always want more of that.
Right, saw a beneficial increase of 1.73%. It's worth noting, though, that in this specific study, there was no statistically significant change observed in triglycerides or LDL cholesterol.
Interesting.
Which just goes to show that responses can vary across trials depending on dose, duration, patient characteristics, you name it. But the appetite suppression itself is a significant finding for weight management.
Absolutely. Appetite control is a huge piece of the puzzle for sustainable weight management. Okay, let's consider another angle. Patients with comorbidities, people who have other health issues going on.
Right, real-world complexity.
Exactly. Solinska et al. From 2017 conducted a study involving 50 obese subjects who also had hypertension and were already on antihypertensive treatment. This is a common scenario.
Very common.
They were given 2 grams of spirulina per day or a placebo for 3 months.
Okay, back to the 2-gram dose. And in this study, the spirulina group showed significant improvements across several anthropometric measures.
Like weight and waist.
Yes. Their body mass decreased from an average of about 93 kilograms down to roughly 89 kilograms. Their BMI improved from 33.5 to 31.7 kilometers, and their waist circumference saw a noticeable reduction from 105.2 centimeters to 103.4 centimeters.
Okay.
Crucially, these improvements were all compared to their baseline measurements and, importantly, were not seen in the placebo group.
Clearly demonstrating the spirulina effect.
Exactly. Beyond that, in terms of blood lipids, they saw significantly lowered LDL cholesterol, the bad cholesterol.
Good.
Additionally, inflammatory markers like interleukin-6 were lowered, and their total antioxidant status improved, along with a better insulin sensitivity ratio. It's a really comprehensive picture of metabolic improvement.
That's a powerful combination of benefits: weight loss, reduced inflammation, and better insulin sensitivity. That covers a lot of ground. And finally, let's look at Ms. Gretke et al. In 2016. Which further demonstrated broader cardiovascular benefits.
Right, moving beyond just weight and lipids.
This trial focused on 40 hypertensive patients who did not have existing cardiovascular disease. They received 2 grams of spirulina per day versus a placebo for 3 months.
And this trial revealed significant reductions in BMI, weight, systolic blood pressure, that's the top number in a blood pressure reading.
Right.
And interestingly, the arterial stiffness index among those taking spirulina.
Arterial stiffness, why is that important?
Well, a reduction in arterial stiffness is particularly noteworthy because it indicates improved vascular health and flexibility. Less stiff arteries mean better blood flow, lower risk.
Ah, I see. So a direct benefit for cardiovascular well-being.
Exactly. This highlights a broader scope of cardiovascular benefits that clearly go hand in hand with weight management. What's truly fascinating here, I think, is the consistency across these different studies.
We keep seeing similar patterns.
Exactly. Demonstrating these anthropometric, meaning body measurement and early metabolic benefits, even with varying doses and durations. It gives us a strong, encouraging signal that spirulina has a tangible role to play in addressing these widespread health concerns.
So when we look at these studies collectively, it's not just a small ripple. We're seeing a significant and consistent wave of tangible changes. Weight, body fat, waistlines, even specific markers like triglycerides and those inflammatory proteins. For anyone looking for a natural, safe approach to complement their health journey, these findings are incredibly compelling. Okay, it's clear that spirulina is showing some really promising effects on body composition and weight. Now let's zoom in even further and dedicate some serious attention to the lipid story.
Cholesterol and triglycerides, yeah.
Specifically its impact on cholesterol and other blood lipids. Now the idea that spirulina might possess lipid-lowering capabilities isn't a brand new concept, is it?
No, not at all. It's actually been speculated in scientific circles since as far back as 1981.
Wow, that far back.
Yeah, with the initial animal trials showing a hypocholesterolemic effect, meaning it lowers cholesterol emerging around 1984.
Okay, so decades of preclinical work.
Exactly. And these early animal studies provide a crucial foundational understanding of these effects, often allowing us to explore mechanisms more deeply than we can initially in humans.
Makes sense.
For example, Iwata et al., back in 1990, conducted a preclinical trial using Wistar rats where hyperlipidemia, high blood fats, was artificially induced through a high fructose diet.
Okay, setting up the problem.
Right. When these rats were given spirulina at concentrations of 5%, 10%, or 15% in their diet for 4 weeks, the results were quite illuminating. The spirulina group showed a significant improvement in their lipid profile, essentially, healthier levels of fats in their blood.
And how did they do that?
Well, this positive change was accompanied by an increased activity of lipoprotein lipase, or LPL.
LPL, that rings a bell.
It's a key enzyme crucial for breaking down and clearing fats from the bloodstream. So more LPL activity means better fat clearance. Interestingly, the study found that the lipid-lowering effect was substantial even at the lower 5% concentration.
Only 5%.
Yes, and it didn't significantly improve much beyond that, suggesting a potentially efficient dose threshold, at least in that model.
So it seems even a relatively modest amount of spirulina can go a long way, at least in rats, in terms of improving lipid profiles. What about other animal studies?
Well, another one by Rodriguez-Hernandez et al. In 2001 corroborated similar lipid-lowering effects, this time in mice with induced diabetes.
Okay, a different model.
Right. They specifically found that a 5% spirulina supplementation decreased hepatic triacylglycerols, which are fats accumulating in the liver.
Fatty liver stuff.
Exactly. And importantly, it improved serum HDL, the good cholesterol, while simultaneously lowering LDL and VLDL, which are the less desirable forms of cholesterol.
So good result in diabetic mice, too. Anything more recent?
Yes, more recently, in 2018, Li et al. Provided further insight. They demonstrated that spirulina given to rats on a high-fat diet for 8 weeks not only significantly increased HDL-C and lowered LDL-C, triglycerides, and total cholesterol.
Usual suspects.
Right, but it also remarkably normalized hepatic steatosis, fatty liver disease, and improved liver function tests.
Wow, so it helped the liver directly.
It suggests a broader protective effect on metabolic organs, yes. Now here's where they delved into the how.
A mechanism.
They proposed that this action was secondary to the activation of the AMP-activated protein kinase signaling pathway.
Okay, AMPK. Sounds important.
It is. To simplify that mouthful, think of this AMPK pathway as your body's master metabolic switch.
Like a thermostat for metabolism.
Sort of, yeah. When activated, it essentially tells your cells to switch from fat storage to fat burning. This pathway, when turned on by spirulina, then effectively downregulates or turns down the dial on the expression of specific genes involved in lipid synthesis.
It changes gene expression.
Yes. Genes like SREBP1C, HMG-CoA reductase, and ACC. The ultimate outcome is a reduction in triglyceride levels and a direct inhibition of the synthesis of new fatty acids. It's like a metabolic reset button, reprogramming how fats are handled at a fundamental genetic level.
That's incredibly sophisticated, really getting into the core cellular machinery to reprogram how fats are handled. It's not just blocking absorption or something simple.
Not at all. It seems to work on multiple levels.
And this leads us to another fascinating and increasingly recognized area of health, the gut microbiota connection.
Yes, the microbiome, crucial.
We're constantly learning how profoundly our gut bacteria influence almost every aspect of our health, from mood to metabolism.
Right.
And it turns out spirulina appears to play a significant role here as well.
Absolutely. Studies have revealed that spirulina can actually alter the composition of our gut microbiota.
Change the types of bacteria.
Yes, and this alteration then directly contributes to its lipid-lowering effects.
How does that work?
Well, this highlights a very important point. Our understanding of how diet impacts health is continually moving beyond simple nutrient absorption to the incredibly complex and dynamic interplay with our gut microbiome.
Right. It's not just what we eat, but how it interacts with our gut bugs.
Exactly. Specifically, research has shown that spirulina supplementation can lead to a beneficial increase in the abundance of certain bacterial groups, such as Prevotella, Porphyromonaceae, Barnesiella, and Paraprevotella.
Okay, those are some names. What do they do?
Good question. Functionally, for instance, Prevotella is known to increase bile metabolism.
Bile helps digest fat, right?
Yes, and when bile acids are metabolized more efficiently, it directly contributes to reducing overall blood lipid levels. It's like a natural cleanup crew for fats orchestrated by these bacteria.
So it's not just the spirulina itself acting, but it's recruiting our own internal bacterial allies to help with lipid management. That's truly amazing.
It is, and it goes further.
Yeah.
Other beneficial bacteria like Alloprevotella and Ruminococcus are known as significant producers of short-chain fatty acids, or SCFAs.
SCFAs, I've heard those are important.
Absolutely crucial. These fatty acids are absorbed by the intestine, circulate through the body, and play a vital role in regulating our energy metabolism. They also directly improve insulin sensitivity via specific receptors.
Helping with blood sugar control, too.
Yes, ultimately leading to a reduction in lipid metabolism disorders and actively helping to prevent conditions like non-alcoholic fatty liver disease.
Wow.
Furthermore, a highly relevant observation in studies was a reduction in firmicutes.
Firmicutes, good or bad?
Well, firmicutes is another broad group of bacteria, and a higher abundance of them has often been associated with higher body weight and increased serum LDL-C levels.
So less is better in this case.
Generally, yes, a better ratio is desirable. And this unfavorable ratio consistently improved with spirulina supplementation. It's a complex, interconnected system where spirulina acts almost like a conductor.
Orchestrating the gut symphony.
Chuckles, exactly. Orchestrating a healthier gut environment that then positively impacts systemic lipid metabolism.
Truly amazing how it works on so many levels and leverages our own internal ecosystem. Now, while those animal studies and the mechanistic insights are incredibly compelling, what about human clinical trials? What do we see when we give spirulina to people?
Right, the crucial step.
Sources point out that the human response can vary, and that's important to acknowledge. Factors like age, race, gender, existing health conditions, comorbidities, and even the precise dose and duration of the spirulina treatment can all influence the outcome.
That variability is indeed a key nuance to remember, but let's look at the broad spectrum of human trials, which collectively paint a very encouraging picture. One of the earliest, by Nakaya et al., back in 1988.
Okay, going way back again.
Involved 30 healthy volunteers who had just mild hypertension or mild hyperlipidemia. They found a significant reduction in total cholesterol within the first 4 weeks of taking 4.2 grams of spirulina per day.
4.2 grams, okay.
Interestingly, this reduction returned to baseline levels when supplementation was stopped.
So you have to keep taking it.
It suggests an ongoing need for the supplement to maintain the effect, yes. In this particular study, though, there were no changes observed in HDL, triglycerides, or body weight, just the total cholesterol.
Interesting. Okay, what about people with more serious issues, like heart disease?
Good point. In 1996, Ramamurthy et al. Focused on a more specific population, 30 patients with ischemic heart disease and existing hypercholesterolemia.
A high-risk group.
Definitely. They administered either 2 grams or 4 grams of spirulina per day for 3 months, and the results were quite dramatic.
How dramatic?
Plasma total cholesterol was lowered by 22.4% with the 2G dose, and a striking 33.5% with the 4G dose.
Over 33% reduction. Wow.
And LDL cholesterol, the bad cholesterol, saw even greater reductions, down by 31% with 2G and 45% with 4G.
45%, that's huge.
Huge reductions. The higher dose clearly yielded higher reductions. Beyond that, they also observed a beneficial increase in HDL-C and a decrease in both triglycerides and VLDL+.
There's more.
Yes, there was a significant body weight reduction of about 2.2 kilograms, roughly 5 pounds, in both treatment groups.
So that's where we start seeing the weight component reemerge alongside those profound lipid benefits. Very interesting.
Moving to a more recent study, Mazokopakis et al. In 2014 looked at Cretan Greek patients who were newly diagnosed with dyslipidemia.
So newly diagnosed, not long-term treatment yet.
Right. A modest 1 gram of spirulina per day for 3 months led to significant reductions across the board.
Even at just 1 gram?
Yes. Triglycerides down by 16.3%, LDL-C by 10.1%, total cholesterol by 8.9%, and non-HDL-C by 10.8%. They also saw an impressive 11.5% reduction in the total cholesterol to HDL ratio,
Which is a key risk marker.
a very powerful indicator of cardiovascular risk. Yes. On the positive side, HDL-C itself increased by a healthy 3.5%.
Nice.
What's particularly noteworthy in this study is that these significant lipid improvements happen without any significant changes in weight, BMI, or blood pressure.
So an independent effect on lipids.
It suggests an independent lipid modulating effect, yes. And incredibly, they noted a significant reduction in overall cardiovascular risk as measured by the Hellenic score, dropping from 15.4% down to a striking 1.9%.
From over 15% risk down to less than 2%. That reduction in cardiovascular risk is truly compelling. So for some, spirulina seems to have independent cardiovascular benefits, even separate from its weight management effects.
It appears so in that study.
Now let's talk about diabetes management, another critical area where spirulina has been studied.
Right. Metabolic health again.
Manny et al. In 2000 gave 15 non-insulin dependent diabetes mellitus patients type 2 diabetes 2 grams of spirulina per day for 2 months. What happened?
They observed significant reductions not just in triglycerides, total cholesterol, LDL-C, and VLDL-C,
The lipid markers.
but also importantly in their blood glucose level.
Blood sugar improvement too.
Yes. Building on that, Purik et al. In 2001 with 25 type 2 diabetic patients confirmed that 2 grams per day for 2 months could significantly lower both fasting blood glucose
By how much?
by 19.3 milli-GDL and postprandial blood glucose, meaning after a meal, by 16.1 milli-GDL.
Significant drops.
Yes. Even HbA1c, which is your long-term average blood glucose marker over 3 months, saw a notable drop of 1.0%.
A full point drop in A1C is clinically relevant.
Very relevant. And on the lipid front, they corroborated reductions in triglycerides, LDL-C, and total cholesterol, while significantly improving crucial atherogenic indices like the TC-HDL-C ratio and the LDL-C-HDL-C ratio. They also saw a favorable increase in the apolipoprotein A1B ratio.
ApoB-A1 ratio. That's a good sign.
Yes, considered a very good marker for cardiovascular health and risk.
Okay, and then Lee et al. In 2008 studied 37 Korean subjects with type 2 diabetes, giving them a higher dose 8 grams per day for 12 weeks.
8 grams, okay. A higher dose again.
This resulted in a significant reduction in triglycerides. What's particularly interesting here is that those participants with higher baseline total cholesterol and LDL-C levels showed even greater reductions.
So it worked better for those who needed it more.
It suggests a more pronounced effect where it's needed most, yes. They also saw an improvement in blood pressure. And the study further highlighted spirulina's antioxidant effects by observing lowered malondialdehyde, a marker of oxidative stress,
That's GA, right?
and increased adiponectin.
Adiponectin. That's the anti-inflammatory hormone from fat cells.
Exactly, the one that signals reduced inflammation and improved insulin sensitivity.
Wow. So many interconnected benefits. It's clear that spirulina is showing benefits across various populations and age groups too. What about kids, for example?
Good question. Samuels et al. In 2002 explored its impact on pediatric patients, specifically 23 children aged 2 to 13 years old, who had hypercholesterolemia stemming from nephrotic syndrome.
A tough condition for kids.
Very. They found that adding just 1 gram of spirulina per day to their standard steroid medications for 2 months led to significantly greater decreases in total cholesterol, LDL, and triglycerides compared to steroid treatment alone.
So it enhanced the standard treatment.
It seems so. It also notably improved the LDL-C, HDL-C, and TC-HDL-C ratios, which is a significant finding for a vulnerable population like children with chronic conditions.
That's really encouraging. And what about our elderly population? As we age, the risk of hyperlipidemia and cardiovascular disease naturally tends to increase.
Right. Several studies in Korea have wisely focused on this demographic. Kim et al. In 2003, for example, gave 12 elderly Korean patients, age 60-75, a dose of 7.5 grams of spirulina per day for 24 weeks.
7.5 grams. Quite high.
Yes. They found significant reductions in triglycerides, total cholesterol, and LDL after just 4 weeks.
Only 4 weeks. That's fast.
And, importantly, these improvements were observed regardless of their baseline cholesterol levels.
Interesting. So it helped even those who started lower.
Apparently so. 2 years later, Kim et al. again, in 2005, studied 51 elderly hypercholesterolemic females aged 60 and above, giving them 7.5 grams per day for 8 weeks versus a placebo.
Okay, placebo-controlled this time.
Right. They reported significant reductions in total cholesterol, LDL-C, oxidized LDL, which is a particularly harmful form of cholesterol.
Right, the damaged kind.
And apolipoprotein B, which is a key component of LDL particles.
So hitting multiple important markers.
Exactly. And finally, Park et al. In 2008 conducted a randomized controlled trial with 78 individuals aged 60-87, administering 8 grams per day for 16 weeks.
Another higher dose study.
Yes. They observed significant reductions in plasma, total cholesterol, and LDL-C, particularly in females who had higher baseline levels.
Again, maybe working better where needed most.
It seems possible. This study also uniquely showed immune-boosting effects. An increase in IL-2, which has anti-inflammatory properties and boosts immunity and generally decreases with age.
Okay, boosting a good interleukin.
And a reduction in IL-6, another inflammatory marker.
And lowering a bad one. Interesting immune effects, too.
So it's not just a general improvement. We're seeing specific impacts on different types of cholesterol and other key markers across a really wide range of people, from children with specific conditions to the elderly.
This consistency across such diverse populations and various health conditions is incredibly compelling. This raises an important question, though. While the general trends are undeniably clear, the variability in response highlights the need to consider individual health profiles and specific lipid imbalances, right?
Absolutely. It underscores that one size may not fit all, but the broad potential is undeniably present and worth further exploration. Okay, we've seen the compelling evidence from clinical trials. Now let's try to connect the dots. Let's explore the proposed mechanisms of action for spirulina's impressive effects on weight loss and blood lipids.
How does it actually do all this?
Right. It seems it's not just one magic bullet, but more like a sophisticated multi-pronged approach working on several levels within the body.
Exactly. One of the primary mechanisms appears to involve the increased fecal excretion of cholesterol and bile.
So getting rid of it directly.
Pretty much. Research by Nagaoka et al. Back in 2005 elegantly demonstrated that specific spirulina concentrates can actually lower the micellar solubility of cholesterol when it's combined with bile acids in the gut.
Micellar solubility, what does that mean?
Okay, think of micelles as tiny transport packages that help your gut absorb fats and cholesterol. Spirulina seems to make these packages less effective at holding on to cholesterol.
So the cholesterol doesn't get absorbed as easily.
Precisely. It leads to a reduced absorption of dietary fats and cholesterol in the small intestine, and consequently, a significantly higher amount of both cholesterol and bile acid is eliminated through your feces.
A direct physical removal.
Yes. It's like a sweep-out effect. Specifically, the phycocyanin residue in spirulina, that blue-green pigment again.
It keeps coming up.
It does. It was shown to increase this cholesterol excretion, directly pointing to its crucial role in these hypolipidemic effects. It's like spirulina helps your body literally squeak out excess cholesterol before it even gets into your system.
So it's like spirulina helps clean things up, both literally in the gut, by preventing absorption, and, as we talked about, on a cellular level, by reducing inflammation.
Exactly. And speaking of inflammation, that brings us back to those powerful anti-inflammatory properties we touched upon earlier.
Right, the phycocyanobulin.
Yes. Reactive oxygen species are often the culprits behind tissue inflammation and damage, but spirulina's unique composition seems to have a built-in countermeasure. The distinctive blue-green pigments, especially phycocyanobulin, which is water-soluble, possess extensive and potent anti-inflammatory and antioxidant properties.
Potent.
Well, phycocyanobulin is structurally quite similar to bilirubin.
Which our body makes.
Yes, which is a powerful antioxidant naturally produced in our own bodies. Because of the similarity, it's capable of inhibiting that NADPH oxidase enzyme we discussed.
The oxidative stress factory.
Right. The antioxidant activity of spirulina has been directly correlated with the quantity of phycocyanin it contains, reinforcing this powerful anti-inflammatory and oxidative stress-reducing role. It's actively calming down cellular overactivity and protecting against damage.
Okay, so sweeping out cholesterol, calming inflammation. Beyond that general anti-inflammatory action, which clearly has broad benefits, what are the specific mechanisms proposed for its more direct weight loss benefits? How does it help shed pounds?
For weight loss specifically, the proposed mechanisms are indeed multi-layered. It's not just one thing.
Okay, lay them out for us.
Firstly, it appears to induce a reduction in macrophage infiltration into visceral fat.
Macrophages. immune cells in the belly fat.
Exactly. Macrophages are immune cells that, when excessively present in visceral fat, the harmful fat around your organs contribute to chronic inflammation and insulin resistance. Spirulina helps to dial down that inflammatory immune response in the fat tissue.
Okay, less inflammation in the fat itself.
Secondly, it contributes to the prevention of hepatic or liver fat accumulation. Preventing fatty liver disease is crucial for metabolic health.
Right.
Thirdly, it reduces overall systemic oxidative stress, which we know plays a role in metabolic dysfunction. And finally, and significantly, it improves insulin sensitivity.
Making cells respond better to insulin.
Meaning your body's cells become more responsive to insulin, allowing glucose to be used for energy more effectively, rather than being stored as fat. These factors collectively contribute to a healthier metabolic state that directly facilitates weight management.
Okay, that makes sense. And we briefly touched on this with one of the studies, but it seems spirulina also directly improves satiety, helping to reduce appetite.
Yes, that's another key proposed mechanism.
For anyone who has struggled with weight, appetite control is often the biggest hurdle.
Absolutely. The underlying theory behind the reduction in appetite is thought to be an improvement in leptin resistance within a critical brain region called the arcuate nucleus.
Leptin, the full hormone.
That's the one. This area of the brain is centrally involved in appetite control. Leptin signals to your brain that you're full and satisfied. In obesity, people often develop leptin resistance.
Their brain doesn't get the signal.
Right, their brain doesn't effectively hear the fullness signals. By potentially improving this leptin sensitivity, spirulina can help your brain more accurately recognize satiety, naturally leading to decreased food intake and fewer cravings.
So it's not just about what it's doing with the fats you've already consumed or even preventing future fat storage, but also helping you consume less in the first place by feeling fuller. That's powerful.
It covers multiple angles.
What about preventing the absorption of fats you do eat? Anything there?
Yes, that brings us to another fascinating mechanism. Pancreatic lipase inhibition.
Blocking fat digestion.
Essentially, yes. One of spirulina's unique components, a glycolipid known as HB2, has been shown to directly inhibit the activity of pancreatic lipase in a dose-dependent manner.
Okay, what does pancreatic lipase do?
It's a crucial enzyme produced by your pancreas that's responsible for digesting and breaking down dietary fats in your gut so they can be absorbed.
So stopping that enzyme stops fat absorption.
It reduces it. By inhibiting this enzyme, spirulina reduces postprandial triglyceride levels, meaning the fat levels in your blood after a meal are lower because less fat has been absorbed. It's like a natural, gentle fat blocker.
Interesting.
And phycocyanin, which we've mentioned multiple times.
Our blue-green friend again.
Chuckles. May also contribute to this lipase inhibition effect.
Okay. And finally, let's talk about some of its specific nutritional components playing a direct role. You mentioned gamma-linolenic acid, GLA, earlier, and maybe even some vitamins.
Yes, spirulina is indeed notably rich in gamma-linolenic acid, or GLA.
Which is a healthy fat.
It's a powerful polyunsaturated fatty acid, yes. Now, GLA is typically formed in the body from the conversion of linoleic acid, LA, another fatty acid. However, this conversion process can unfortunately be hindered by various common factors.
Like what?
Mineral deficiencies, excessive alcohol or tobacco use, certain infections, the natural aging process, and severe medical conditions can all slow down that conversion.
So we might not make enough GLA ourselves.
Exactly. And a deficiency in GLA can have significant negative consequences, potentially worsening arterial thickness, contributing to hypertension, and exacerbating dyslipidemia.
Okay.
Thus, the direct presence of GLA in spirulina offers a readily available source that can help to counter these very issues, basically bypassing the need for that internal conversion step.
So you get the benefits directly.
Right. Additionally, spirulina naturally contains vitamin B3, also widely known as niacin.
Niacin. I know that's used for cholesterol.
Exactly. Niacin itself is independently recognized and clinically used for its ability to significantly improve dyslipidemia by favorably impacting cholesterol and triglyceride levels.
So spirulina provides that too.
It contributes. What's truly fascinating here, when you pull it all together, is how spirulina isn't relying on just one single mechanism.
Oh, it sounds like a whole toolkit.
It really does. It seems to work through multiple synergistic pathways, from direct impact on nutrient absorption and excretion to influencing our gut bacteria to calming cellular inflammation, impacting appetite signaling, inhibiting fat digestion, and even providing direct beneficial fatty acids and vitamins.
Wow.
all working together to achieve its wide-ranging effects. It's a truly holistic nutritional solution from a single microscopic organism. Pretty amazing when you think about it. Hashtag tech outro.
Well, we've certainly covered a tremendous amount of ground in this deep dive into spirulina. It's pretty impressive stuff. Let's try and bring it all together and recap the key takeaways for everyone.
Sound good?
We've seen compelling evidence that spirulina shows really promising benefits for weight loss, helping to reduce BMI, body fat, waist circumference, and even aiding in that crucial area of appetite reduction.
Yeah.
Beyond that, it has demonstrated significant and consistent improvements in blood lipid profiles. We're talking effectively reducing total cholesterol, LDL-C, the bad stuff, triglycerides, and VLDL-C, while also beneficially increasing HDL-C, the good stuff, and improving important apolipoprotein ratios.
A pretty comprehensive lipid improvement profile.
Exactly. And as we've explored, its potential extends far beyond these core areas, offering potential improvements in insulin resistance, providing potent antioxidant and anti-inflammatory properties, and even potentially helping with blood glucose and blood pressure management.
It really touches on many aspects of metabolic health, and from the numerous studies we reviewed, the dosages varied, but it seems a range between, say, 2 to 8 grams per day appears to yield consistent benefits across different populations and conditions.
2 to 8 grams, okay.
Although it's worth noting, some trials did explore doses as high as, I think, 19 grams per day.
19, wow.
Indicating its general safety even at relatively higher concentrations, which is reassuring.
That is reassuring. So what does this all mean for you, our listener, as you consider your own wellness journey? It's clear that this deep dive into spirulina reveals a really compelling story for a remarkably simple, ancient algae tackling some of our most prevalent and interconnected modern health challenges. Quite remarkable, isn't it?
It really is.
Now, while the evidence is indeed compelling, it's always important to remember the nuances.
Right. Anyways.
We noted that the response to spirulina supplementation can vary among individuals. Factors like their specific health profile, existing comorbidities, maybe genetics, and even the precise dose and duration used in the studies can influence the outcome.
Which highlights the ongoing need for further research. Larger, perhaps longer term, and even more diverse clinical trials are needed to broadly confirm and optimize these benefits across all populations.
Right. But the trajectory of the research is undeniably exciting, pointing towards a potentially powerful natural adjunct to our current health strategies.
Absolutely. And this raises, I think, an important question for us all. In an age of complex medical interventions and ever-evolving pharmaceuticals, how much untapped potential truly lies in returning to some of nature's simplest yet remarkably potent nutritional solutions?
That's a great question.
Considering spirulina's ancient origins, existing for billions of years, and its broad array of demonstrated health benefits, how might reintegrating such foundational superfoods into our modern diets fundamentally shift our approach? Maybe move us more towards preventative health, rather than just reactive treatment.
Could truly ancient wisdom hold some of the most profound answers for our modern well-being? Something to ponder, definitely.
What's it for thought?
Absolutely. Something for you, our listener, to mull over as you consider your own holistic wellness journey. Think about what aspects of this deep dive resonated most with you, and perhaps explore how small, natural additions might fit into your approach to health. We hope you found this deep dive as enlightening and thought-provoking as we have.
Hope it was useful.